YouTubers, how are you doing? I hope you are doing well. I hope you are staying safe as well. In our last class we discussed factorization method. Today we are going to look at completing the square, and that area we assist most especially those that are in the terminal class. Sometimes they used to set a question, they will give you some expression, they will ask you that what are you going to add to it to make it a complete square. So please make sure you take care of that and just watch this lesson and you understand the concept very well, inshallah. So if you are new here, subscribe to my channel, share it with friends and family, those that you know can benefit from the channel, as well as if you have any comment and if you've done the assignment I gave to you in the last class, you can submit it in my comments below. I will check it and I will look into it. Okay, I'll look into it. Now let's go to class. Let's go to class. Look at this one. We want to, the question asks us to find what must be added to this expression to make it a perfect square. To make it a perfect square. That's how they used to set the question most time. Or they can also conclude the question by saying, then factorize the expression. Okay, they can also complete it like that. Now let's look at it now. Assuming this one is a perfect square, that's the first thing. Let's suppose that. Suppose x squared plus 6x plus k is a perfect square. It's a perfect square. It's a perfect square. And that is equal to x plus a square. So assuming we have this thing like this, assuming we assume that this one is a perfect square and it's equals to this. Don't forget the way I put it. It's in an expression, in an quadratic expression, you must have the constant, the second power, the first power, and the constant. Okay, so it's a constant k, you must have it like that. Now let's go now. So we are having x squared plus 6x plus k is equals to x plus a all in square. This one is a perfect square. Don't forget how to expand that. We're not going to go to that one at a time today. Plus 6x plus k will be equals to x squared plus 2ax plus a squared. You will remember this one. You know how to do that. When you expand this, you're going to have this. Okay? So we're going to have that. We're not going to go to that one at a time. Now, by comparing the coefficients, let's compare the coefficient of x first. Comparing coefficient of x. Coefficient of x. So where is the coefficient of x that I want to compare? Let's look at it. We have x squared here, that one has gone. The coefficient of this one and this one, that's what we're looking into now. So we have coefficient here is what? 6, isn't it? Is equals to 2a. Don't forget coefficient of x here is 6, coefficient of x here is 2a. Coefficient, the number in front of x here and the number in front of x here. Do you get that? Fine. So let's take it off from there. So we have 2a is equals to 6 and a is equals to 3. Do we get it up to that level? Fine. Now let's move on now. Comparing the constant now. Let's compare the constant. What of the constant? What do we have in the constant here? K and a squared. In the constant we have what? We have k is equals to a squared. The constant here and the constant here. That's k is equals to a squared. Is it clear up to that? Fine. Those are the constant terms. Let's put it like that so you'll not be having confusion. Constant terms. Now the next thing that we're going to look into, what's our a? We've already gotten the value of a to be 3. K is equals to a squared. That means k will now be equals to what? 3 squared. And that is what? 9. That is 9. Do we see it now? So therefore, let me try and clean some parts. Okay, let me keep writing for now. Therefore, 9 must be added. 9 must be added. 9 must be added to make it a perfect square. Okay, 9 must be added to the expression. Let me clean this one, and this one we're moving. Therefore, 9 must be, don't forget where we stop here. 9 must be added to the expression, to make it a perfect square. That is, the expression must be like this. When we check it, you're going to see it. It must be like x squared plus 6x plus 9 will be equals to x plus 3 squared. Don't forget the value of our a. What's the value of our a? That is 3. The value of our a is 3. So we have it like that. Do you see it up to that end? Note something here. I want you to note something here. So we don't need to be going by open the brackets with it. When you understand this, what I want to put down on the board. The quantity to be added, is, that they want to give us a clue, something that we have to be using. So we don't need to be going one at a time like this and get our answer again. The quantity to be added will now be they have the square, let me go like that, the square of half of the coefficient of x. As soon as you know this one, you don't need to like go one at a time before you get your answer again. Okay, note this point now, because in the second example I'm not going to go by expanding one at a time again. Just go straight with this point. This thing is saying that the quantity to be added will be the square of half of the coefficient of x. As long as you add the square of half of coefficient of x to this expression, you are going to get this. How do we know that one? The square of half of coefficient of x. What is the coefficient of x is? What is half of it? 3. And the square of that 3 will be what? 9. Do you see it now? Half of this one is 3. Square of it will now be 9. So as long as you know that one, you're good to go. Okay? So take note of this point. Let's go to example 2 now. Now let's continue now. Look at example 2. What must be added to y squared plus 5y to make it a perfect square? That's the first thing. The question also goes further by saying factorize the results. They want us to also factorize the result. So here with this statement here, the square of half of coefficient of x. So we don't need to like expanding and stopping ourselves again. We go by just a 3-step now. The first thing is, what's the coefficient of y here? So solution, the coefficient of y, the coefficient of y is what? Minus 5. Please don't forget, you have to respect the sign. You carry it along with the sign, okay? Carry along with the sign. Don't forget half of coefficient. So half of that coefficient will now be what? That's the second step. Half of minus 5. What's half of minus 5? Is what? That's minus 5 over 2. Okay, that's half of it. So what is the square now? So those are the 3 steps that I'm going to take. Square of minus 5 over 2 will give you what? Plus 25 over 4. That's very good. Do you see it now? And that's your answer. Just have to go and write it there. So therefore, to make it a perfect square, what you must add to it, it will now be y squared plus, sorry, it's minus that is there, minus 5y plus 25 over 4. That is what you must add to it, and that's what makes it a perfect square. Do you see it now? Do you see it now? So this one must be added, and then you're going to get your perfect square. That's the answer. That's the first answer. The second one says factorize the answer. How do we factorize it? So this is a perfect square now. Don't forget that. How do we factorize it? You just write it back the way you have it. Y squared minus 5y plus 25 over 4. When you factorize it, it will give you y minus, what do you have here? 5 over 2 all in square. And that's the factor. That's the factorize of it. That's the result. That will be the factors of it when you factorize it. That's what you're going to get. Okay. Now, I hope we're good to go. We're good to go. Sometimes they might not give you a whole number like this. They might give you in fraction form like that. So it's not necessary. They have to give you a whole number. Sometimes they give you fraction. They'll give you mixed number like that. So I would like us to go to example 3 so we can explain that one now. Now let's look at example 3. This is the expression given to us now. Okay, let's look at that expression given to us. Solution to that, we have k squared plus 1 over 2k. Isn't this the question given to us? What are we going to add to it to make it a perfect square? The first step, don't forget the 3 steps. The 3-step coefficient, half, and square. So the first step will be, what's the coefficient? Coefficient of unknown. Coefficient of our k will be what? This is the coefficient 1 over 2. Okay, the coefficient of the first power 1 over 2. Half of it will now be, that's the second step. Half of it, half of coefficient. Half of coefficient, let's find this one, will now be what? 1 over 3, 2. Change it to improper fraction, you're going to have 3 over 2, isn't it? Times, that is half, times half, and that will give you what? 3 over 4. Do you get it now? Do you get it now? We have been simplifying it further now. Then, step 3 will now be what? Square. Square the coefficient, square this the result that you have now. Will now be equals to 3 over 4 all in square, and that will give you what? 9 over 16. So what must be added is this now. Do you see it now? So it's not every time you're going to give you a whole number. So now what must be added will now be k squared plus 1 over 2k plus 9 over 16, and that is what makes it a perfect square now. Do you see it now? What make it a perfect square? Let's go and factorize now. We're going to write it back to factorize. So factorize will now be what? When we factorize it, we now have k squared plus 1 over 2k. Can write it back like that, the way they give it to us, plus 9 over 16 will now be equals to k squared and k plus 3 over 4 all in square, and that will be your answer. That will be your answer. Do you see it now? Do you see it now? So that's how simple it is. So anytime they ask us to find a number that you must add to a particular expression to get it, to make it a perfect square under this quadratic expression, these are you're going to go on it. Do you get it? Now let me give you some questions to try. Let me give you some questions to try. When you're going, make sure you try it. When you solve it, finish, drop it in my comments below. I would love to see your result. Okay. So here is a question I want you to try. What must be added to the following expression to make it a perfect square? After you've gotten that, then you now factorize your result. So see you in the next class. Well, see you, bye.